Subtracting fractions. So if we're going to subtract fractions, we have to have a common denominator. So in problem 1, it says 5/6 minus 1/9. So we can see that the denominators are 6 and 9. So they're not common yet, so we have to find a common denominator. Now you may know, if you know your multiplication tables really well, you can look at 6 and 9 and know that the first multiple is 18. But these are small enough that even if you didn't know that, what you'd do is you'd start off with multiples of 6. So you'd say 6, and then the next multiple of 6 is 12, and then the next multiple of 6 is 18. Well, as soon as I see 18, I stop, because I know that if I go 9, the next multiple of 9 is 18. So 18 is the smallest multiple of 9. Then I come back and I say 6 times 3 is 18. Whatever I do to the denominator, I must do to the numerator. So I'm going to have to multiply that 5 by 3 as well. 9 times 2 is 18. And once again, if I do it to the denominator, I have to do it to the numerator as well. So this gives me 5 times 3 is 15. 6 times 3 is 18. Minus 1 times 2 is 2. And then 9 times 2 is 18. Now I just do the subtraction. So keep my common denominator of 18, and then 15 minus 2 is 13. Once I have my answer, I have to make sure that it's not reducible. So what I do is I say, well, 13 is prime. So if this fraction, 13 over 18, is reducible, it's because 13 times something gives me 18. And there's nothing. I can't multiply 13 by anything and get 18. So we're done. In problems like problem 2, we have 17 over 24 minus 3 over 16. Now, these ones may be too large for the denominators of 24 and 16 for us to just find it by multiples. So what we can use is prime factorization. So I take 24 and I break it down into its prime factors. 24 is 2 times 12. 2 is prime, but 12 is not. It's 2 times 6. 2 is prime, but 6 is not. It's 2 times 3. And the 2 and the 3 are both prime. So what I'm going to do is rewrite 17 over 24. I keep the 17, but the 24 I write as its prime factorization, which is 2 times 2 times 2 times 3. Now I'm going to do the same thing with 16. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. So I'm going to rewrite that denominator of 16 as 4 factors of 2. So we've got 2 times 2 times 2 times 2. The next goal is to make these two prime factorizations look identical. So when I look in the first one, I see that there are 3 factors of 2. And in the second one, there are 4 factors of 2. So I'm missing 1 factor of 2. So I multiply by 2. If I'm going to do it to the denominator, I have to also do it to the numerator. So now in my first fraction, I've got 1, 2, 3, 4 factors of 2 and a factor of 3. If I look at my second fraction, I just have 1, 2, 3, 4 factors of 2, but I'm missing the factor of 3. So I multiply by 3. If I'm going to do it to the denominator, I have to also do it to the numerator. Now I've got 17 times 2, which is 34, and I have to do this multiplication. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24, and 24 times 2 is 48. So I get 34 over 48 for my first fraction. For the second fraction, the numerator is 3 times 3, which is 9. And then since I still have 4 factors of 2 and a factor of 3, I know I'm going to get 48 for this denominator as well. Now we want to subtract, so my denominator stays the same, 48, and I need to do 34 minus 9. So I write 34 minus 9. 4 minus 9 I cannot do, so I need to borrow from the 3, make it a 2, and make my 4 a 14. 14 minus 9 is 5, and then I just carry down my 2, so I get 25. So now I have 25 over 48, and I want to make sure that that's not reducible. Well, if I think about 25, 25 is 5 times 5. So 5 is its only factor. Nothing times 5 is going to give me 48. So they don't share any common factors in the numerator and the denominator. So I know that this is fully reduced. In our last example, number 3, we've got 27 over 48 minus 5 over 96. And you may think to yourself, I'm going to have to use prime factorization. The first thing I would do is find some multiples of the first 48, just to see if we really have to use prime factorization. So what's 48 times 2 going to be? Well, 8 times 2 is 16, carry the 1, and 4 times 2 is 8, plus 1 is 9, 96. So by doing a little bit of playing around in the beginning, we can kind of get ourselves out of having to do the prime factorization, because now we know that 48 times 2 is 96. So now we'd have to do 27 times 2. That's 7 times 2 is 14, carry our 1. 2 times 2 is 4, plus 1 is 5. So we get 54 over 96 minus 5 over 96. Common denominator of 96 stays. And now we have to do the 54 minus 5. So 54 minus 5 is going to give us 49. And now we want to see if this is reducible or not. So the first thing I know is that 49 is 7 times 7. So if 96 has a factor of 7 in it, then it's reducible. But I don't know if it does or not, so I have to break it down. That's going to be 2 times 48. And 48 is 6 times 8. I don't even really have to go any further than this, because I know that there's not going to be a factor of 7 inside my 2. There's not going to be a factor of 7 inside my 6, and there's not going to be a factor of 7 inside my 8. So 49 over 96 is fully reduced.